So today we're going to start our last unit here, Chapter 9, talking about transformations, different types of transformations. And I don't think this is going to be a brand new concept for you, but we may add our own little spin to it. So for today we're going to talk about translation, which is basically a slide. Right? We're going to slide figures in a plane. We can use vectors to help us do that. We'll talk about vectors in a minute as well. Okay? So, if we're going to translate, translation means that we're going to move every point of a figure the same distance in the same direction. Again, we're just going to slide it. Imagine just taking a shape and sliding it in a particular direction. And so we'll take every vertex. We'll move every vertex of a shape, and that will help us move every point. Okay, we need to be able to differentiate between our original shape and our new shape, our original figure and our new figure. The image is the new figure. The pre-image is the original figure. And whatever we name the pre-image, if it's a triangle, say triangle ABC, then the way we name the image is we use primes. We use the same letters, but we put apostrophes after them. And we read it as A prime, B prime, C prime. And it'll tell us how to, and it'll help us recognize which one is the image, which one is the pre-image. And then last but not least, this vocabulary term, isometry. If a transformation preserves length and angle measure, then it's an isometry. In other words, if what you start with is congruent to what you end up with, then you've used an isometry. Okay? Translations are isometries. When we slide a shape, we're not going to change the size of it or what it's shaped like. So they're going to be congruent. The pre-image and the image are going to be congruent. Okay? So let's talk about how to create an image from a pre-image. So if we were to graph quadrilateral ABCD, and you have a grid there in your notes, I'll let you go ahead and graph the vertices. A is at negative 1, 2. B is at negative 1, 5, C is at 4, 6, and D is at 4, 2. Take a second to graph those. Now we want to find the image of each vertex after the translation. And here's the definition of the translation. Here's the translation rule. Basically what we want to do is we want to slide 3 in the x direction right 3 in the x direction, down 1 in the y direction. Our rule is x plus 3, y minus 1. To do that, we're quite literally going to add 3 to the x coordinate and subtract 1 from the y coordinate. So for A, to create A prime, we would take negative 1 plus 3. Negative 1 plus 3 is 2. And then we would so we're going to add 3 here and subtract 1 here. And so 2 minus 1 is 1. To get B prime, we're going to do the same thing. We're going to add 3 here and subtract 1 here. So negative 1 plus 3 is 2. 5 minus 1 is 4. And for C prime, we're going to, again, add 3, subtract 1, and get 7, 5. And for D, we're going to add 3, subtract 1 to get D prime, and we get 7, 1. Now with these new vertices, we can graph our image. And again, I'll let you try that on your grid there. So take a second and graph those new points. Make your new quadrilateral. And when you do, you should get this. And then again, make sure you label your vertices. So A, B, C, D. And then A prime, B prime, C prime, D prime. We need to be able to differentiate between the image and the pre-image, and so we have to make sure that we label our vertices. Okay? That's all there is to it. We're just going to add 3, subtract 1 from every coordinate. Now, as the translation rules change, what we do to the coordinates change as well. So we're not going to always add 3 and subtract 1. This is what we had to do here. Okay? Here's another translation. Triangle, RST. So vertices 2, 2, 5, 2, 3, 5. Go about finding the pre-image. Sorry, we already have the pre-image. Go about finding the image and graph it if we have this translation rule, x plus 1 and y plus 2. Go ahead and stop the video, give it a shot, and graph it, start it back up, and make sure that you have it correct. Okay, so that's our rule, x plus 1, y plus 2. R prime, we're just going to add 1 to 2 and add 2 to 2, so get 3 comma 4. For S prime, we should get 6 comma 4. And for T prime, we should get 4 comma 7. And when we graph it, it should look something like this. So basically, our preimage was has slid up and to the right. Okay? And that's pretty much all there is to it. Now we can work backwards from an image to the preimage. And here's one way we can do that. So if the image of this translation rule is the segment P prime, Q prime with endpoints, so P prime, we'll try to make this as accurate as we possibly can. So at P prime, we're at -3 comma 4, and at Q prime, we're at 2 comma 1. And we want to find the coordinates of the endpoints of the preimage. So we've slid up 4 and right 4 and down 7. So to find the new points, to find P, we know that to find P prime, we had to add 4, subtract 7. So to go to P prime, we had to add 4, subtract 7. To go the other way, we have to go the opposite. We have to do the opposite rule. We have to subtract 4 and add 7. Right? So instead of taking the original points and adding 4 and subtracting 7, we're going to do the opposite, which is subtract 4, add 7. Right? So this is going to be -7, comma 15. And then Q is going to be subtract 4, add 7. So it would be -2, comma 8. And that's where the preimage will be located. Okay? So just going backwards from the rule. So instead of adding 4, subtract 4. Instead of subtracting 7, add 7. Okay? Now you also need to be able to write the rule for the translation from a graph. So all we've got to do is find the preimage, and the preimage is this triangle here because it's A, B, C, and then find the image, which is this guy right here, which is A prime, B prime, C prime, and we've got to figure out how did A go from here over to A prime. Not how far did it go, how did it get there, right? And so our rule is going to be to take our preimage and do what to it? Well, to go from A to A prime, we had to walk back 1, 2, 3, 4. So that means we take our x and subtract 4 from it. And then we had to go up 1. So we had to take our y and add 1 to it. Okay? And so since we do x comma y, x is always in the horizontal direction, y is always in the vertical direction. That's how we want to apply our rule. And we want to check the rest of the points to make sure they're following the same rule. So C, if we walk back 1, 2, 3, 4, so x minus 4, and then up 1, y plus 1, and we get there. B, if we go back 1, 2, 3, 4, and up 1, we get to B prime. So that rule seems to hold for all the points. So that must be our translation rule. And that's all there is to it. How do we get from the preimage to the image? Okay? Now, we can use vectors to slide. A vector is a quantity that has both direction and magnitude. Okay? And it's represented in the coordinate plane by an arrow drawn from one point to another. So it's going to look like a ray, but because it has direction and magnitude, it's going to stop, right? And we know that rays don't technically stop. So what's an arrow? It has an initial point. The initial point is just a starting point, and it has a terminal point. The terminal point is the ending point of the vector. Okay? Now, vectors have component forms. They have components. And you use these a lot in engineering, physics, forces, the study of forces, which is statics. Component form. There's a horizontal component, there's a horizontal component and a vertical component, and that corresponds to your X and Y movements, right? The horizontal component goes left and right, that's the X-axis. Your vertical component goes up and down, that's your Y-axis. Okay? So, vectors you can express in two different ways. You can show it visually, graphically. So here's a vector. Its initial point is here at B, and its terminal point is here at C. So it does end. So it's not an array, it's a vector. And you see it, the direction is what? Down to the right. The magnitude would be the length of this, right? Which we could also find, but for right now, we just want the component form. The vertical component. From B to C, how did it move vertically? Oh, sorry, not vertically. We want the horizontal component first. Horizontal, because that's the X direction, and we do X before we do Y. So again, we'll pose the question, but in a different way. From point B to point C, how did it move horizontally? And it moved to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So the horizontal component is 9. The vertical component is going to be how far did it move up or down. So you go 1, 2. So it went down 2. And so when you write this in component form, you use these greater than, less than symbols. So 9, -2. And that will tell you that the vector moved to the right 9 and down 2. Okay, that's how we write this in component form. When we write the vector itself, we call it vector BC, and we use this half arrow above. We don't want to use an actual arrow because it would look like a ray, and this is not a ray. It's a vector which ends, which has a terminal point. And so we write it as that, BC with a half arrow above it. Okay? So you try it. Name the vector and write its component form. Take a second and think about it. Start the video back up and see if you're right. Okay, this vector we name it xt. Oh wait, start with the initial point first, t, x, and then the terminal point, and that's how you would name it. And its vector form would be, well, the horizontal component. How far did you move horizontally from t to x? Well, none. How far did you move vertically from t to x? You moved 3. And so you'd write it like that, 0, 3. Okay? Name this vector and write its component form. So give it a shot and see what you come up with. Okay, so this should be ST, and the component form should be what? From S to T, we went back 1, 2, 3, 4, 5, 6, 7, 8. So -8. In its vertical form, we did not go up at all vertically, so it's -8, 0. Okay? Now, go back for a second. I'm going to go back a couple of examples and talk to you a little bit about the distance that the vector covers. That would be its magnitude. If I find the distance from B to C, that would be the magnitude. Well, how would we find that distance? Well, because we're talking about component form being the horizontal distance, the horizontal component, and part of it is the vertical component. If we drew those in, we would make a right angle, because horizontal and vertical lines are right angles. And you can see that we now have a right triangle, where this component is 9, and this component is -2. It doesn't matter if it's 2 or -2. We're talking about distance, so it's going to be 2. So to find this distance, we can just use Pythagorean theorem. So -2 squared plus 9 squared would equal, call it x. So we go 4 plus 81 equals x squared. Then 85 equals x squared. And then we know we would just square root this to find the actual magnitude, which is the square root of 85. And we won't worry about typing it in and getting a decimal. So the magnitude would be the square root of 85. Right? And it would be the same for the rest of these two also. Right? We would take 0 squared plus 3 squared and set it equal to the actual magnitude, x squared. So we get 3 squared, which is 9. Square root, and so x would be 3, since we're talking about distance. Okay? Same thing for this guy. You would take the horizontal component squared plus the vertical component squared and set it equal to whatever the magnitude x is, x squared. So we get 16 equals x squared, square root, and so the magnitude would be 4. Wait, back up. Last time I checked, 16 or 8 squared is not 16, it's 64. And so the magnitude would not be 4, it would be 8. That makes more sense. Okay? All right. Last but not least, how do we apply vectors to our translations? Well, if we have a triangle LMN, where the vertices are at 2, 2, 5, 3, 9, 1, if we're going to use a vector to translate, then all we do is we use this as this right here is our horizontal translation, this is our vertical. In other words, this is our x translation, this is our y translation. That's how we're going to change the pre-image coordinates. We're going to subtract 2 from the x's, and we're going to add 6 to the y's. Okay? So what would that look like? Well, if L is 2, 2, then L prime would be, subtract 2, you get 0. Add 6 to 2, you get 8. M is 5, 3. So when you translate it, you're going to get M prime, which is going to be located at 3, 9. And then for N, your coordinates are 9, 1. When you translate it, N prime is going to be, subtract 2 from 9, you get 7, add 6 to 1, and you get 7. And so there is your image from your pre-image. And you can graph it and see it if you'd like. Okay? And that's it. That's all there is to translations. We'll talk about more transformations next time. Homework's out in Canvas. Make sure you have it done by next time.